Good morning. Today we are going to be learning about 8.1 geometric mean, but before we get to that, we are going to look at this similarity in right triangles discovery sheet because that'll help you get an idea of this theorem that we are going to learn. So, right now I have 3 right triangles in my image here. I know that this one is also right because of that linear pair. And I know some properties of triangles. Each triangle has 180 degrees. So since I have 90 and 65 here, I can solve for this third angle. So really quick, I'm going to solve 65 plus 90 plus, we'll call it x for now, is 180. You can take your calculator. You should get 155. And you subtract. I'm just going to subtract it like this and then know that it can't be negative, and I get 25 here. It's a little shortcut if you don't want to have to retype everything. So that angle, guys, is 25. Now, notice how this is 90 here? I know, personally, that this will also have to be 65, but maybe you guys don't recognize that. So, let's solve. I need to take 90 minus 25, and like I said, you get 65 degrees. If you don't recognize it, that's fine. You can still solve for it. That means we are left with 25 degrees down here. So we have 3 similar triangles. That's why it's called similarity in right triangles. We have 3 similar triangles because they are all 65, 90, and 25. So I've got this little triangle on the left side. I have the medium triangle on the right side. And we have the largest triangle that encompasses all of them. Now, you'll notice that there are variables here that it's asking us to solve for. And we don't have enough information anywhere to do Pythagorean theorem, even though they're all right triangles. So we have to use something else. And this is where our theorem comes in. So I am going to scroll down, and I actually redrew all of these triangles. So my little triangle, the one I have in red, is right here. And then my medium triangle is next. I'm sorry that they're not the best drawings, but I redrew them and rewrote their side lengths. So they're all facing the same way, so we don't have to really think about it too much. Now, think back to the last chapter. We're still not done with setting up proportions here. If you think about the last chapter, we could set up cross multiply and solve. Okay, so if I was wanting to solve for x, there are multiple x's and I can't mix other variables. So I would find x here. Let me just circle it in purple. It is in 2 spots. So it is what I will call the long leg in this triangle, and it is the short leg in this triangle. And I can match that up to its buddies, so the long leg and short leg within the same triangle, and I can set up a proportion and solve. Now, that gets a little tricky when you don't have these singular little triangles drawn out, so you can easily find your proportion to set up, because you'd have to be like, okay, this is the long side, and it's shared, so this is the short side and the other triangle, and then this is the short side, and this is the long side, and you have to really figure it out. So I'm going to give you a quicker way to think about this, but let's finish talking about it. You simply cross multiply to solve here, and then we will simplify our square root. Anyway, we'll get back to that. I'm not going to finish that out now. I want to talk you through the simplified version, or the way I like to think about it. If you'd prefer to just find your congruences, by all means, do that. I think I erased too much. There we go. Oh, man. Okay, so the simplified version. What you can do is you can think about, in this case, x is the altitude. Okay, we'll talk about the altitude in a second. And the altitude is the repeated piece. Okay, guys, so we already talked about the definition of an altitude, but the altitude drops down from a vertex to 90 degrees of the other side of the triangle. So x is an altitude. Anytime you see an altitude, whether it's a number or a letter, if you are trying to solve for the altitude or one of these two pieces of information, the altitude will be repeated. So just like we had set up, you repeat it across the diagonal, okay? So from there, you use these individual numbers, 4 and 6. You cross multiply to solve. Just like we had before, we have x squared equals 24. Take the square root. And I did mention that you would have to reduce your radical. Sorry, I didn't really leave a ton of room. I'll leave more room the next time. We just talked about this. So you can split this and do the square root of 4 and the square root of 6. So your answer here for x is 2 square root 6. And yes, the radical needs to be reduced. Okay? Now you might be asking, y and z are not the altitude, so what do I do then? Theoretically, you could now do the Pythagorean theorem to find each of them. You have right triangles, you have enough sides, but you have something weird to work with the 2 square root 6. I'm going to show you the other shortcuts in case you don't have enough sides to do this. So now, if I'm trying to solve for y is different. It is shared. Y'all notice that it's part of both the red and purple triangles. It's got both highlighting. So we are looking at the red and purple triangles. We have y is the hypotenuse in this triangle, and y is the short leg in this triangle. I know it's the short leg because it's across from the smallest angle, if you're wondering. And then I have to find my scale factor or the buddies that go with it. So 10 is the hypotenuse here. 4 is the short leg here. So I have my scale factor, 4 and 10, and then the y's. Or I guess the scale factor would not be 4 and 10 because they don't match up. Sorry, misspoke there. Anyway, you'll match some different things up. We'll solve. But if you look at it in this shape, we have y being the shared, and then based on this other information, we have the side of the small triangle, and then we have this whole side of the big triangle. So that's where the 10 came from. 4 and 6, or 4 plus 6 is 10. So 4 and 10 is not our scale factor. We do need to set it up so that this leg is the repeated piece. That means the legs will be at a diagonal to each other. And then you just fill in your other two pieces of information. You'll cross multiply to solve. You get y squared equals 40. So you guys see what I mean, that 4 and 10 is not the scale factor because they're not even in the same fraction. So they can't be a scale factor. Anyway, back to the problem. You have to simplify this so you can take out a 4 and a 10. We just discussed this the other day, and you get 2 square root 10 as your answer for y. Okay, now z. Z is super similar to Y. You'll notice, though, that it's part of the purple and blue triangles, the largest and the medium triangles. So let's take a look. We're looking at Z. So we have two Z's, part of the purple and blue, this one, and this one. And then you'll notice that we have to match up. So we need the hypotenuse Z and the long leg. Now the Z's are going to be at diagonals to each other. Whatever the legs are, whether it's a number or a variable, is the repeated piece, and then you fill in your extra information. You cross multiply, and then you also have to, oh, sorry, that should not be an X, that should be a Z. Fix that on yours. Anyway, you take the square root, and then you do have to reduce. So Z, can take a 4 out of here as well, is equal to 2 square root 15. So we've got our 3 missing sides as simplified radicals. And one other thing, just like we wrote for X over here, for this specific problem, Y and Z are both legs of the big triangle. And the legs are the repeated piece. I really want to emphasize, guys, that it's just the legs or the altitude that are repeated. It does not matter if it is the variable or not. Okay, so let's take one last look at this Z here. Notice the Z is the leg of the biggest triangle. So we're looking at the purple triangle. From there, you use the medium's triangle's large leg and the big triangle's hypotenuse. Okay, we'll get to some more examples. Make sure you have this written down, that the altitude, if you're trying to solve for something with that information, is the repeated piece, or the legs would be the repeated piece. And you know which one to use based on what you need to find. So let's actually go to our real notes. The first part doesn't have a ton to do with this, but it's just really short. We're talking about geometric mean. We're using geometric means to solve problems involving right triangles. So that's actually what we are doing today, is geometric mean within triangles. So a geometric mean of two positive numbers, a and b, is the number x, such that a over x equals x over b. So you have to have x squared equals a times b, which means that x equals the square root of ab. That's literally what we were just doing, okay? So the geometric mean of 9 and 4 is 6, because you just multiply those two and then take the square root, and that's square root of 36 is 6. So we're going to find the geometric mean between 2 and 50. If that's all they tell you to do, you just multiply them. Oops. And then you take the square root. So we got the square root of 100, which is 10. I'm going to say x, but they didn't even tell us a variable. So if you just write 10, that's fine. So if you think back, Algebra 1, I taught you guys that geometric sequences exist. This is true here too. If you have 2 and 50, you are trying to figure out what you can multiply here to get a term between them. It's kind of like a normal mean, an average, except instead of adding the same number over and over, you're multiplying. That's why you're multiplying and taking the square root instead of just adding and dividing by 2. Anyway, if you plug a 10 in here, you multiply by 5 each time, and you have your geometric sequence. So that's kind of a little behind the scenes. You guys try this review, try real quick. Pause the video. All right, hopefully you paused. You just multiply these two and take the square root. So you get 6. You don't have to think about your geometric mean, you don't have to think about your geometric sequence necessarily, but if you wanted to, you could put it in between here and you would know, oh hey, I am multiplying by 2 over and over. Okay? Now, all I really want you to know how to do is multiply and then take the square root like you have here. Now, we have theorem 8.1, which is really exactly what we were just talking about on the previous page. If the altitude is drawn to the hypotenuse of a similar triangle, then the two triangles formed are similar to the original triangle and to each other. Okay, so that's what we're doing. You've got your large triangle, medium, small triangle. It says if CD is the altitude to hypotenuse AB of right triangle ABC, then you have all of these similar triangles. They're all similar to each other. So we are going to start out by writing a similarity statement, identifying the three similar triangles in the figure. This is just what we had on our last page. We didn't write a similarity statement, so it's not like exact, but we have a 90 here. I'm going to even use the same degrees so we don't have to rethink those through. 90, we're going to say that's 65. This is 25. That means this is 65, and this is 25. So we need to have three triangles with a similarity statement. I'm going to start with the smallest triangle. So we have EFH. I went from the 65 to 25 to 90, which means if I go to my medium triangle, my red one, I need to go 65 F, 25 G, 90 H. And then my largest triangle, 65 would be E, 25 is G, and then 90 is F. So make sure for each one you are following the same pattern as you go around. That way you know they're similar on their similarity statements. All right, turn your page, pause, try this one. All right, so C, hopefully you paused. All right, a similarity statement, identifying the three similar triangles in the figure. This is C, guys. If you write out the same degrees again, they might not be, but that can help you visualize. Oh, let me do that. If we have L, M, N, that's the biggest triangle, we're doing 25, 90, 65. Then we have our medium triangle, LOM, is 25, 90, 65. And MON is 25, 90, 65. So we've got C. The rest of them mix something up. All right, here's our theorems that we did our little pre-learning for. Right triangle geometric mean theorems. We have geometric mean altitude theorem. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of the altitude is the geometric mean between the lengths of these two segments. So this is saying that this that altitude splits the hypotenuse into two smaller segments, x and y, and you just take the geometric mean of them. If you like setting up a proportion, the altitude is the repeated piece, and the two smaller portions are in the leftover sections. The geometric mean leg theorem tells us the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of a leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So what this is saying is if you have this leg that you're either trying to find or you're given, the adjacent leg would be x here, and then you use the hypotenuse of the big triangle. Or if you have the other one, A, use the adjacent leg and then the hypotenuse as well. The large triangle, either B or A in this case, are the repeated pieces at a diagonal in your proportion. Okay, so let's do just a couple examples. We have to find a lot here though. So use the geometric mean with right triangles. I'm going to start with E, the altitude. We know the altitude is the repeated piece. Sometimes that is a number, not a letter. That's fine. The altitude breaks the hypotenuse of the big triangle into two smaller pieces. They fill in these blanks, which means, oops, that's the wrong number, 24, not 25, which means we cross multiply to solve. You get e squared equals, let me see, 144 it looks like. You take the square root here, and this is a nice one. E just equals 12. Now, yes, you could, like I said, just do Pythagorean theorem for C and D now because you have enough information. That is totally legal. I'm not going to do that, okay? Let's go ahead and move on. We're going to find D. So D is the leg of the big triangle, which means it is the repeated piece. It could also be a number. It would be okay. D works with this adjacent leg, 6, and then the whole hypotenuse, 30. Okay, so we cross multiply. We get that D squared is equal to 180. Take the square root, and then you have to simplify this. So this actually breaks down into 36 and 5. You get 6 square root 5 for D. Okay, and lastly, C. Okay, C is the other leg of the large triangle, so it is the repeated piece. You look at the adjacent leg of the medium triangle now. It's just across, we have 24, and then you use the whole leg of the big hypotenuse, I should say, of the big triangle. It is 30. This is quite large when you cross multiply. You get that C squared is equal to 720. You take the square root, you have to break it down. You can break it into 144 and 5, which means that C, yes, is 12 square root 5. And you found all of your missing information. Yes, you could have used Pythagorean theorem for 2 of them, but that's fine, okay? I want to go back up here and rewrite what I wrote on our original thing. So the altitude theorem, the altitude is the repeated piece. And then for the leg is the repeated piece. Okay? Now, it could be number or letter. We've only seen letters so far and had to solve. It could be something different. All right. You can pause me if you need to. I'm going to go to this last one. Pause me, try this one. All right. So E, notice, find your variable you're trying to solve for. E is the leg of the large triangle, which means we are using the leg theorem. We look at the opposite side here, 16. Since E is the leg, it is repeated, add a diagonal to each other, and then we have to use this whole side here, which is 20. A lot of kids mess up on that. Make sure you're using the whole side when you need to. You end up with E squared is equal to 320. You take the square root. This one actually has it as decimals, so you will find that it is 17.9. All right. Tomorrow you'll have a delta over this, and I'll be back so I can answer any questions that you have. I'll let the sub know if you have questions too. And with any extra time, you can work on the delta from yesterday. Have a great day.